All right, hey everyone. So we're going to continue with two populations from Chapter 10. We already went through, 1 through 4, so we're not going to do 5. We're going to do 6, but I'm going to do it here. All right, so question 6. A researcher who was a convicted felon, which makes it better, claims that 61% of guys and 50% of girls send inappropriate text messages. So I'm going to make a little thing up here. We're going to need a lot more space here, so just use this area to kind of do it. So we have boys and 61% of guys, so that's what they're claiming, so that's going to be the big P. And 50% of girls, that's going to be 2, so P is going to be 0.5 D. So a statistician decides to test this theory, takes an SRS of 1,200 boys, so N is 1,200, and finds that 58% of them, so P hat in this case would be 0.58. You could find X, something over 1,200 is 58, but you don't need to. SRS of 1,400 girls, and that P hat is 52. So this just says, describe the sampling distribution of the difference in proportions of inappropriate text, and we're going to do guys minus girls just so that we're consistent. So with guys minus girls, we're going to say 1 and 2, so we could really call these 1s, and these would be 2s. All right, so describe the sampling distribution. So center, the mu, P hat 1 minus P hat 2 is just P1 minus P2, which is 0.61 minus 0.50, 0.11. The shape. So the sampling distribution of P hat 1 minus P hat 2 is approximately normal by the large counts condition. The large counts condition says N1, P1, so that's 1,200 times 0.61, which is, let me do that in my head, 732, N1, Q1, so Q is just 1 minus P, 0.39, 468. So that's for the boys. Now we got to do N2, P2, 1,400, 0.50, 700, N2, Q2, 1,400, 0.50 is 700. All of these have to be greater than 10, which they are. So center, shape. Now the next thing is spread. So the spread of the sampling distribution is P1, Q1, N1, P2, Q2, N2. Now I'm using P's and Q's here because I have the P's and Q's. Don't use the hats. You only use the hats here when you don't know the P. So 61, 39, 1,200, 0.5, 0.5, 1,400, square root, and this is going to give us .0194. And we have to look at the 10% condition. So as long as there are more than guys and 14,000 girls, which, duh, yes there are. So what's the probability a statistician would find a sample difference of 0.6 or more extreme than that? Now I'm using 0.6 because the statistician found this. He went out and sampled and found those two values. So 0.58 minus 0.52 is 0.06. So what's the chance he or she would find that difference? So here's all the p hat 1 minus p hat 2s. We know that 0.11 is in the middle, and we found 0.06. Is 0.06 strong enough to assume that the researcher's claim is wrong? Because we're assuming 0.11 is a center because that's what the convict told us. But we found this, so let's see how easy it was. So that's what we're trying to calculate, the probability of that. Sorry if you can't see. So that's going to be norm CDF minus 99, 0.06, the mean, and then that standard deviation. So 0.0194, and hopefully my math is right. We get that. So does he have convicting evidence to say the researcher's claim is less than 0.11? Well, yes, because there was a 4% chance he would find that. So I would say so. So we'll just make up some fake alpha, 0.05. I mean, that's smaller than any conventional alpha. Okay, that's 6. All right, number 7. As part of the Pew Internet and American Life project, I don't even know what that is, researchers conducted 2 surveys in 2012. The first survey asked a random sample of 79 teens about their use of social media. Actually, let me just look at this. Okay. And the internet. A second survey proposed a similar question to a random sample of 2253 U.S. adults. In these 2 studies, 80% of teens and 69% of adults use social networking sites. So, calculate the standard error of the sampling distribution. Now, in this question, we do not know P1 and we do not know P2. Those are unknowns, and that's why they're going to make us do a confidence interval. We have to kind of guess what they would be based on our surveys. So the standard error, so SE, P hat 1 minus P hat 2. Oh, so teens would be 1, adults would be 2. So now instead of the P's, we're going to have to use the P hats. So let's see, 80% of teens, 0.8, 0.2, and they surveyed 799 plus this. All right, so that's the standard error. What does this information provide? Well, this is what this means. Well, someone's having a good time up there. which we don't know that true difference, but if we did, it's going to be that far away from it on average. Obviously, pause this if you can't keep up. So construct and interpret a 95% confidence interval for the difference. So we're going to do this. State. All right, so I'm really going to do this one, you know, really drawn out, really long, and then the rest of them are kind of do a little quicker. You want to estimate where P1 is the true proportion of teens who you know, use social networking, and P2 is the true proportion of adults who use social networking. All right, that's the state. The plan, there's a plan. Jack, stop talking. All right. So we're going to do a 2 sample Z interval for P1 minus P2. So now we got to do the conditions. So the first one is random, so which it is, the data come from 2 independent random samples of teens and adults. When we're doing 2 samples, it's important to say that they're independent because you don't want to have teens and adults that are within the same household, because then that's dependent. And if it doesn't say if it is, then you might want to write down, assuming that they are, this condition would pass. 10%. So there needs to be at least 7,990 teens, and there has to be 2,2,530 adults. And then we need large counts. So in this case, N1 P hat 1 799 times 0.8, and then that's 799 times 0.2, because that's N1 Q hat 2. And then N2 P hat 2, N2 Q hat 2, and then all of these need to be greater than 10. Okay, and you could easily verify that. So what are we going to do? Here's the formula. P hat 1, Q hat 1, N1, P hat 2, Q hat 2, N2. So P hat 1 was 0.80. P hat 2 was 0.69. Now, this is the critical value. So we're doing a, what is it? 95% confidence interval. So that's going to be inverse norm. So let's do this. 0.025, comma 0, comma 1. 1.9 I don't know, 6. And then 0.8, 0.2, 799 plus 0.69 times 0.31, 2253. But we already know that value, it's going to be this. If we work this math out, we get 0.076, 0.144. All right? So state plan do conclude. We're 95% confident the true difference in proportions of teens minus adults is captured in this interval. So it's going to be somewhere in this range. Anywhere from 7.6% to 14.4% is going to be that difference. So we really could go one step further and say this interval suggests in social networking. Maybe I should have changed this to social distancing, but that's clearly not the case. Adults are doing it better than the teens. And it has to be more, because if we're doing teens minus adults, that's going to be a positive number, so that's positive. All right, does your interval give convincing evidence of a difference in proportions? Well, yeah. If 0 was in the interval, then that's evidence of no difference. Because if we get P1 minus P2 is 0, then they're both using the internet the same. So 80% and 80%, that would be the same. All right, that's number 7. Okay, number 8, I'm going to kind of blow through this one quickly, and this will be the last one. All right, 2 independent random samples of teenagers and adults were asked if they used Tinder to find dates. The results are shown in the table. So teenagers, 159 are using Tinder, 110 are not using Tinder. That many teens, adults, total. So the proportion, let's make the teenagers minus adults. So let's make the teens be 1, the adults be 2. So P hat 1, in this case, using Tinder. So we want the yeses. So 159 out of 269 are using Tinder. And then P hat 2 is 124 over 401 are using Tinder, and I could calculate that stuff. So to do this in the calculator, we're going to do, so we're going to go to stat test, and then it's a 2 sample, so it's not a test, it's got to be an interval. So 1 prop z int we already did, so 2 prop z int. So 2 prop z int. Now these have to be whole numbers. So 159, 269, 124, 401. And it wants a 95% confidence interval. Well, there it is. There's P hat 1, there's P hat 2, there's the interval. All right, so it's just assuming all conditions are met, but basically, you know, without getting into the real fancy part, it's still going to be this. P hat 1, Q hat 1, N1 plus P hat 2, Q hat 2, N2. You might be better off just maybe doing the fractions Or you could use the percents, whatever one you choose, because this is what the calculator gave us. So, 0.591, 1 minus 0.591 over the total teens, 269, plus 0.309, 1 minus 0.309, whatever that is, 401, bam, and yeah. All right, now that's exciting. That's an exciting confidence interval. All right, and then does the interval give convincing evidence? Yes, since 0 isn't in the interval. All right, we're going to stop there. We're going to do hypothesis test on the next video.